Hey everyone, my name is Alfred, and in this video, I'm going to show you how to predict a univariate time series with a Gaussian process model. And then after that, I will adding some feature from the frequency domain to see the effect of the frequency domain features on our prediction. And finally, by tuning some hyperparameter of Gaussian process model with the Bayesian optimization, I will show you the effect of the hyperparameter on the prediction. So let's get started to see the effects of different situations on our output. Okay, now I open time series prediction with GP model, and here is the file. I set the model name to the GP. It means a simple Gaussian process model for our training process. The prediction height is set to the 20, the train percent set to the 80% for the training and 20% for the testing. The delay value is set to 1 to the 50. And here is used FSST. It's set to the false. It means do you want to use frequency domain features in your training process or not? I set it to false. Here is the Gaussian process model initializing, and here is the variable of Gaussian process model. Here is the variable of the Bayesian hyperparameter, maximum iteration, maximum time for the optimization. From the line 37 to the end of the code, the steps of time series prediction are defined and set up. Loading data, preprocessing data, dividing data into the train and test sets, building suitable data for the model, and model creation. In the model creation function, we can create a structure of the deep learning or any other model like SVM, Gaussian process model, MLP, multi-layer perceptron, or fuzzy model. And finally, after the creating our model and training it with our training dataset and training target, we need to evaluate our model with the test data. And after that, if the model is acceptable on the test data, we need the future forecast. And here is the future forecast. Okay, let's run the code and see the output. We need to fit a univariate time series data of one column Excel file. Here is a sample of our benchmark, global ice volume, and here is the input data of global ice volume, and we need to predicting the future of this data set. Here is our training data. The MSE and RMSE of data is bad. The R2 is very good. It's kind of overfitted. Here is our test data set, and it is really good. And here is the training data set, the prediction on the training data set and prediction on this test data set. This is divided by this green line. As we can see, it is fitted very well. But the future forecast isn't really good. If I zoom in this section, I think it is better result. After this sample, it diverges. Okay, let's close all this stuff. Let's change the model. Let's use the feature frequency feature in our training model by setting this value to be true. Now we use the frequency domain features to training our model. And choose again the globalized volume and see the output result. Here is our frequency domain features. And if I change the size of view to something like this, it's good. As we can see here is the range of our frequency in this dataset, and here is our time span. And the magnitude of the frequency is here. By adding the frequency features to our model and train data, regression lines one is really overfitted, I think. The test data isn't bad, it's good, 98, and doesn't. Actually, I think it's good. And the output, the prediction output for the trained data set is here, and the prediction output for the test data set is here. Here we have a big error, and here is another big error. But I think it is acceptable because it gets through the trend. As you can see, it's truly follow the trend. And the good point is it doesn't diverge. After 20 samples, it doesn't diverge. If I set it to the 100, I want to see when it's going to diverge. And re-evaluate this section code for the future forecasting. It doesn't diverge in the 100th sample after the end of our data set. But I think the prediction isn't really acceptable. And let's run this model. With this model, the Gaussian process with a hyperparameter tuning will run. And run again the code and choose again our benchmark dataset, and maximum iteration for this Bayesian optimization is 10. And as we can see, our hyperparameter are sigma and basis function, kernel function, and standardized variable. From the second sample, we have some improvement in okay. Here is the prediction of the Gaussian process model with a hyperparameter tuning. So let's increase this value to 150 and the prediction. As we can see, we use a bigger data set, a much bigger data set, or a much complicated data set. We're going to see very differences between a simple Gaussian model and a Gaussian model with Bayesian hyperparameter tuning. But in this model, in this data set, I couldn't see any a big or very big improvement on the prediction. Well, as we can see in the future forecast result, I don't know, but I can see a much big improvement on the forecast. Actually, I think if we have a much bigger data set or much more complicated data set, we need more to the hyperparameter tuning. And those situations, I think the hyperparameter tuning will be more needed in our training process. Okay, if you enjoyed the video, please like and subscribe my channel. Thank you very much.